In this example, I'm going to show you how to find the vertex, locus, and the directrix of the parabola. Now, from our notes, from our reading, we know that when we have x squared equal to 4py, that means our graph is has the axis of symmetries is along the y-axis. Now I put plus and minus here, meaning it's like if you have plus, meaning I open up, you have minus, I open that down. If you have y squared, then the axis of symmetry is along the x-axis. So if it's plus in the front, that means I have open to the right, minus open to the left. So here's a problem A. I have x squared equal to 12y. So since the equation involves x squared, that means the axis of symmetries is along the y-axis. Okay, and because the coefficient of the y is positive, so therefore I have the parabola is opened up. Now, my next step is to find p. So to do that, I'm taking the coefficient 12, okay, which has to be equal to 4p. So I divide by 4 equal to 3. So this 12 here must be stand for 4p, so I set 12 equal to 4p, and I solve for p, I have 3. Alright, now also I know that from base our equation, this is a parabola with the vertex of origin at the origin. So that means our vertex has to be 0, 3. Because here is our focus. Here's our focus. Our focus has to be 0, 3, because I know our vertex is 0 and 0. So a distance from a vertex to the locus is p units. Since p is 3, so I have 0, 3 right there. Now I'm going to use the p to graph. So I find a vertex, I find the locus. Now, if you want to find the line of directrix, which is by equal to minus 3. Since the directrix is perpendicular to the x-axis, which is also the axis of symmetry. Okay, this is our y-axis, and here is our x. Since our y-axis is the axis of symmetry and directrix line, we have to be perpendicular to this line. So it has to be horizontal line. Okay, and the distance has to be 3 units from the vertex. Since p is 3, so a distance of the directrix should be 3 units from the vertex. So that's why I know that right here, that will be our directrix line path y equal to minus 3, like that. So here is. Now I'm going to graph parabola. Now to graph a parabola, I'm using the step technique that in our notes. I know that I graph it open up. And now I know a p is 3, so I'm going to extend 3 units up, should be here, and then should be another one here. So a box right here. Okay, this from here to here to be 2p, so it'll be 6. Right here should be 2p, right here should be p. And right here should be also 2p, and right here is p. So I draw 3 up, and then 2p here 6 from the x-axis, and then 2p here which is 6. So I got this 2 point. So our graphs now, all you have to do is join this point to the vertex, and it look like this. So that is our parabola with directrix is y equal to -3. Our vertex is 0 and 0. Our locus is 0, 3. Let's try do part B. Part B, I have y plus ax. I'm going to rewrite this as a standard equation by minus ax both sides. So I have y squared equal to minus ax. Because our equation involves y squared, so based on our reading, I know that the axis of symmetry is along the x-axis. That means our graph opens sideways. So I can either left or right. Because I have minus here, this means open to the left. Okay. So at like 8 equal to 4p. So I divide by 4. So p is 2. Okay. Once again, this is our standard, and see that this is my vertex right here is 0 and 0. Okay, so right here is my vertex. Okay, our locus should be at -2, 0. Okay, because remember the locus is too distant from the vertex. I know that our graph is open on the left, so open on the left like that, almost look like this. So if the vertex is 0, 0 here, 2 unit to the left would be -2, 0. So our locus would be -2, 0. And the line of directrix is perpendicular to the axis of symmetry. And we know that the axis of symmetry is along the x-axis. Right here is the axis of symmetry. So therefore, our directrix should be this line, which is perpendicular to the axis of symmetry. In this case, it's along the x-axis. So this line here is x equal to 2. Okay. Okay, we use the box again and draw our parabola. So from here to here should be so I'm gonna draw a box. Uh-oh, I don't know what I did here. Okay. So the value p, I'm gonna use the value p to draw a box. So the box should be is extending p unit from the origin along the axis of symmetry in the direction in which the parabola opens. So I know it open to the left, so I should have 2 units. Give me 1 unit here, 2, and then that is p, and then I should have 2p along the side of the axis symmetry. So right here is the axis symmetry, so I'll go 2p this way, and then 2p that way, and then 1p like that. So this is from here to here to 2p, here's a 1p, and here 2p, this is 1p. Now up here 2, so I go up 2, 4, 4, 2. So this is the point here that I need to help me to draw the parabola. So let's connect them together. Now I'm take the vertex, connecting this point. As we go through the point, it's hard to draw from here and go like that. So that is our parabola.